Next, we have a table that gives the number of millions of people in the United States who live below the poverty level in selected years. Let's see what we need to do with this. Create a scatter plot with x equal to the number of years after 1900. Find a quadratic model that approximately fits the data. Does the model seem like a reasonable fit? Use the model to predict the number of people living below the poverty line in 2013. I've already entered the data for those years. The window I selected is from 0 to 25 and from 30 to 50, according to the data we had. So let's take a look at the graph. Well, it has somewhat of a dip. We need to find a quadratic model for it. So here's our scatter plot for part A. We need to find a quadratic model for it. So let's calculate number 5. We do want to check the graph, so let's store that in the variables. We're storing the y variables. Enter and enter. And we want to calculate that. Enter. Now we have 100 0.114 x squared minus 2.322 and 45.445, that 4 being the next number, will be our equation. Let's go to y equals. We'll need to take off this 9 we have down here. We'll clear that. We have the scatter plot in the graph. So here's our quadratic function. With that graph, we can see these 2 points kind of miss, but the dip is going there. The graph, let's do what the equation was. Y equals 0.11114 x squared minus 2.322 x plus 45.445. And it does seem a reasonable fit below the poverty level. So y equals 0.11114 times, that would be 23 squared minus 2.322 times 23 plus 45.445. And when I do that calculation, I do find out that this is 52.345, so 52.3 million people living below the poverty level in 2013. Now we have a table that shows the monthly insurance rates for a $100,000 life insurance policy for smokers aged 35 to 50 years of age. So we have the age listed and the monthly insurance rate in dollars. Entered this data in the calculator. The window we have used is from 35 to 50 and 17 to 35. And this is our graph. The first question, enter the scatter plot, the data. Does it appear a quadratic function could be used as a model for the data? I would say yes for that. If so, find the best fitting quadratic model. So let's find that model. I'm going to calculate that. We're looking for number 5, a quadratic model. We will want to graph this and save it. So we'll go to variables, y variables. We want to save it and we'll save it in function 1, and we'll go down and calculate it. So here is our equation. We would round this to 0.052, negative 3.234, and 66.656 will be that equation. And let's look at the graph. That appears to be a pretty good fit. Have our graph, and we'll remember, I'll write this down for you. Y equals 0.052 x squared minus 3.234x plus 66.656. So yes, it appear a quadratic function could be used to model, and here is our best quadratic model. Okay, in our next slide, we need to find the power model that is the best fit for the data. We'll go here, we want to calculate, and now we're looking for a power function. So looking down the list, there's our arrow to go down. We'll find a power function is here, and that is A. So that's the one we want. We want that one. Again, we'll want to save this because we'll want to graph it. This time, when I go to variables to save it, I'm going to save it a y variable. I'm going to save it as a function, but I'm going to go down to number 2 and save it in y2 so I can have both graphs there at the same time. Enter that, and we'll go calculate that. So notice it's a times x raised to the b. So it'll be a to 3 decimal places we 0.011 x squared raised x to the 2.038 will be my power function. And y equals, we'll find that it's there. We'll look at the graph. Now that is the quadratic one first, and here is the best of the power function. Let's compare the two models by graphing each model on the same axis. Which data appears to be the better fit? Well, if you remember, this one that went to the points was a quadratic, and this one coming across here was the power function. So it appears that the quadratic is the better fit.